here the directions say factor completely. The first thing we want to do when we factor completely is see if there's a common factor in all the terms. So as we look at this first one here, we look at 5n squared minus 40n plus 35, and we notice that a 5 is a factor of each of those coefficients. So we can factor out a 5. And then we're going to factor that out and see what we have left over. 5 times what gives me 5n squared, that's an n squared. And then 5 times what gives me negative 40n, that would be a negative 8n. And 5 times what gives me positive 35, and that's 7. So we factored out a common factor. Now what we want to do is see if we can continue factoring that trinomial. And so what we do when we factor a trinomial is we're going to keep our 5 here. Don't forget to put the 5. We're going to put 2 sets of parentheses because we're going to try to figure out to see if there's 2 binomials or two-termed polynomials, so binomials, that multiply to equal 8x or n squared minus 8n plus 7. And so what we do is we first put in these first 2 numbers here, or values. And so we have to figure out what can we multiply together to get n squared. And our best choice is just n times n will give us that n squared. We then want to look and determine what signs go here. So we should have a sign that goes here and a sign that goes here, a plus or a minus. The way that we do that is we look at this last sign, the positive. And that's how we look at it. And here's our different options. So it's positive, and we think, how can we get a positive number at the end? To get this last number here, we have to multiply these 2 values. And in order to get a positive 7, we can either multiply a positive times a positive, or we can multiply a negative times a negative. And so we're going to have 2 positives, a plus and a plus, or a minus and a minus. The way that we determine which one it is by looking at this sign. And so since it's a minus, these are going to be 2 negatives. And again, the reason for that is when we take a negative number times a negative number, that will give us the positive 7. Now we want to figure out what numbers go here. This one turns out to be nice and simple because the only factors of 7 are 1 and 7. And so we know we have to have a 1 and a 7. We can go ahead and check. Also, with this, we need to get this negative 8. And so when we multiply, the way that we get the negative 8 is multiplying these 2 and then adding when we multiply these 2. So let's just check this quickly. We have negative n minus 7n, and that would give us the negative 8n. So this right here, I know it got a little sloppy, is our answer. This will multiply out to equal this right here. So that's factoring. We found the factors that will multiply together to equal that original thing. Coming over to number 40. First we're going to look for a common factor. We have an x squared minus x minus 2, and there's no common factor in there besides 1, and we don't factor out a 1. So what we're going to do is we're going to put our 2 sets of parentheses. In order to get an x squared, we need an x times an x, because these 2 multiply together to give us the first term. Then what we're going to do is we're going to figure out our signs. Here we have a negative on the last term. The way that we get a negative is a positive times a negative. So one of our signs has to be positive and one of them has to be negative. And then we have to figure out the factors of 2. Well, the factors of 2, again, this is a simple one. It's not making us work real hard for it, are just 1 and 2. And so we're going to put a 1 and a 2. But we also have to make sure we get the center term here. So the way that we check the middle term is we multiply these 2 and multiply these 2 and combine them. So we're going to have 2x and a negative x, or minus x. And if we combine those, we get x. And so looking up here, we're close. We want a negative x. We got a positive x. So what happens if you get the opposite of what you want is you switch your two signs. So we had a positive 2 and a negative 1. We're going to switch those signs, and we're going to make this a negative 2 and a positive 1. Now, to check our answer here, let's multiply this whole thing out just to check. So x times x is x squared. X times a positive 1 is just x. Multiplying these, we get negative 2x and minus 2. We have these two terms here. That gives a negative x minus 2. And that is what we wanted. That was our original. So this is our answer. And we know it's our answer because we checked it, and it ends up multiplying to equal the original. Looking at our next example here, we want to see if there's a common factor. We got a 1, a 12, and a 35. There's no common factors. So here we're going to put our two sets of parentheses. We know to get a p squared, we'll need a p times a p. Our last sign here is a positive. The only way to get a positive 35 is to take either a positive times a positive or a negative times a negative. The way that we determine that is looking at this sign, and so we are going to want two negatives since that's a negative there. And then we want to think, what are the factors of 35? Well, we have a couple choices for this. We have 1 and 35 or 5 and 7. So it's not normally, if it's a bigger number like 35, it's not normally the 1 and 35. Sometimes it is, so we can't rule it out. But we're just going to try the 5 and the 7. So we're going to put that there, and then we're going to check to see if that gives us the negative 12. We don't really have to check the p squared because we chose p times p to equal p squared. We chose the negative 5 times the negative 7 to equal the positive 35. We know those will work, but we do need to check the middle ones. So we're going to check this. So this is negative 5p and negative 7p, which does in fact equal negative 12p. And so that's our answer for that one. Coming to 42, first thing we want to do is check for a common factor. 6v squared plus 6v minus 540. That does have a common factor. 6 goes into each of those. So we have a 6. And then we're going to factor out that 6. We're left with v squared plus v, and thinking 6 times what equals 540? Well, that's going to be 90. And now we're going to try to factor further. Don't forget the 6. We have a 6. We're going to have our two sets of parentheses to see if we can factor this. And so to get the v squared, we need a v here and a v here. To get a negative 90, we're looking at this sign here, negative, we need a positive and a negative. And now we're thinking of the factors of 90. So we have 1 and 90, there's actually a lot of them, 2 and 45, 3 and 30, 4 doesn't work, 5 and 18, 6 and 15, 7 doesn't work, 8 doesn't work, and then 9 and 10. And so once you get good at these, you might realize these faster, especially when there's just a 1 out here. They're easy to factor. So let's, since this is a 1 here, I know I want to combine this with this when we put our numbers there to get a 1. And that only works, well, yeah. So we're going to put a 9 and a 10. I'm choosing 9 and 10 because they're only 1 apart, and that's what I want here, 1 apart. And it's a positive 1, so I'm going to make my bigger number positive. I'm going to make that a positive 10. and I'm going to make this my negative 9. And so there's the factorization of that one. Here we have 4 more. I'm going to move through these a little quicker unless we get to something that's a little different, which these are different, so we won't move as too quick. When we want to look for a common factor, we see that a 6 goes into all of those, so we're going to factor out a 6. That leaves us with 5r squared plus just an r minus 6. Now these are a little different because they have a 5 here, not just a 1. So we have to think through these a little more. So we still have our 6. Don't forget the 6. We're going to put our 2 sets of parentheses. In order to get a 5r squared, we can't just put r and r because we need a 5r squared. So we're going to put a 5r and an r. Those are the only, we're thinking of the factors of 5, and just 5 times 1 gives us 5. So we got a 5r times r. We have a negative here, and so if we have a negative, in order to get a negative 6, we have to have a positive times a negative. Now these signs might have to change later, so we're going to have to mess around with this a little bit possibly, unless we guess right on our first one. And so we have a positive and negative, and now we're thinking, how do we get 6? We need these two to multiply to equal 6. Well, we can have a 1 and a 6, or a 2 and 3. In different orders, we could have 1 and 6, or 6 and 1. So let's just put these in here. Let's just try putting a 1 and a 6. I might erase this and change again. So we're trying 1 and 6. By doing this, again, we don't have to check to see if we have the 5r squared or the negative 6. We're just going to check this. So that's r combined with this, which is 5r times negative 6 is negative 30. R, which equals negative 29r. That is not what we want. We want a positive r, so that's definitely not it. So let's go back and try something different. So 1 and 6 didn't work. Well, let's try 6 and 1 then. Let's switch these things around. So here we have 6r minus 5r, and that does in fact give us r, which is what we wanted here. And so this is the correct factoring. We ended up doing a pretty good job guessing. We didn't have to even try the 2 and 3 because the 6 and the 1 worked. The next one, we're going to look for a common factor again, which we do have a common factor of 6, it looks like. 6 goes into each of those. So we have 6, 5m squared plus 12m plus 4. And so we want to put our 6 here. We're going to put our 2 groups of parentheses. We want to figure out what signs. Well, we can figure out our signs. This is a positive, so how do we get a positive 24? We either need a positive times a positive or a negative times a negative. The way that we determine which one it is look at this sign. So we know we're going to have a positive and a positive. I should have said these signs, although it doesn't matter that much. Now, how do we get a 5m? Well, that's like the last one. The way to get a 5m is a 5m and an m will give us the 5m squared. And then we want to think, how do we get this 4 over here? Well, we can either have a 1 times 4 is 4 or a 2 times 2. And so we're going to try these different numbers and see what happens. So I'm going to write this in a different color, but let's try 1 and 4. So that gives us m, and that gives us 20m, which is 21m, which is not what we want. So we're going to back this up, and we're going to try 4 and 1. Trying 4 and 1, that's a 4m plus 5m. which adds up to be 9m, which is a little closer, but it's still not right. Close doesn't count here. So it's not 4 and 1, so hopefully it's 2 and 2, because that's our only other option. And so we're going to try 2 and 2 here. We're going to check this, that's 2m. Check this, that's a plus 10m, which does equal to 12m, and that's what we wanted. And so this is the factors of that original question there. Coming down to the next one, hopefully all this practice is helpful. We first want to see if there's a common factor. We have a 16n squared, a 24n, and a 9. Nothing goes into all three of those, so there is not a common factor, so we just skip that part, and now we can see if we have some factors that will multiply to equal this. We can look at our signs again. We have a plus, so we know we need the same sign, either a plus and a plus, or a minus and a minus. In this case, looking at this sign, we know we need a plus and a plus. Now 16n squared. In our other ones, we really only had one choice. When we had a 5r squared and a 5m squared, the only factors of 5 are 1 and 5. But for 16, we have different choices. So I'm going to write them down here. We have a 1 and 16, 2 and 8, 4 and 4. And those are our different choices. So, and then for our 9, when we get to our 9, we have 1 and 9 and 3 and 3. So there's a lot of combinations here. We could end up using a lot of guess and check. My first instinct is usually to not use these. So I would probably use some other options. So I'm actually going to use the 4 and the 4. So 4n times 4n will give me 16n squared. And then for the 9, I'm going to try 3 and 3. And I think this works. So we know the 4n times 4n will give the 16n squared. We know the 3 times the 3 will give the 9. So we need to check to see if we can get this 24. And so we check these. So we're going to multiply 3 times 4n is 12n. And then multiply these. 4n times 3n is 12n, which is 24n. So this is our correct answer. We can write it this way, but if you notice, we just have something times itself. When we multiply something times itself, we can use exponents, and so we could write this as 4n plus 3 squared. We also learned a way that we could have realized that this is a perfect square trinomial. We learned that if you look at the first term, I'm going to erase some of this stuff here so it doesn't have so much around it. We learned that if we look at the first term and it's a perfect square, and we think, well, what squared gives me 16n squared? That would be a 4n. And if we look at the last term and it's a perfect square, which it is, the perfect square is 3, or if you square it, square root it's 3. And then if you multiply the 4n times the 3, which is 12n, and double it, which is 24n, and if that equals this middle term, we know it's a perfect squared trinomial. And if you notice this here, we have our 4n here, 4n, and this was a positive 9. So we have a positive 3. So 4n plus 3 squared, that was another way we learned how to factor that, by checking if the first term is a perfect square, the second term's a perfect square, and then looking at those square roots, if you multiply them and double it, will it equal that middle term? This last one only has 2 terms, and so this is another special case that we learned. So if it's a binomial, we still want to see if there's a common factor. 16r squared and 9, there's not a common factor there. So what we do, if it's 2 terms and their subtraction, we call it a difference of squares. And we learned that it fits the form a squared minus b squared. The first term squared minus the second term squared. We learned that if it fits that case, which it does, because what's the square root of this? That's 4r. What's the square root of this? That's 3. So it fits this case. Our answer is just going to be 4r plus 3 times 4r minus 3. And that's how you can factor a difference of squares. So if it fits the form a squared minus b squared, it's going to factor to a plus b times a minus b, which is really saying the square root of the first plus the square root of the second, and then the square root of the first minus the square root of the second. And that is factoring completely.